example number one is a two-column proof. So we need to, again, still talk about a few vocabulary words here. So the first one is theorem. So a theorem is a conjecture that is proven. So a conjecture was a rule we used in inductive reasoning, right? So inductive reasoning, we came up with a pattern, and then we used that pattern to create a rule, and then we used that rule to make predictions. So we called that rule a conjecture because it wasn't proven. In order to prove it, we would have to have tested every possible case. And in a lot of those, right, the whole point of inductive reasoning is you're lacking all the information you need. You don't have all the information. You don't have all the possibilities. And so you're using the pattern to predict what's going to happen. So here, we're not using inductive reasoning. We're going to be using deductive reasoning. Now we skipped 1.6, section or topic 1.6, which was deductive reasoning. But essentially, deductive reasoning is where everything's gonna follow from what comes before it. The argument should be airtight. There's no assumptions. It's everything that you have follows from what comes before it. So if you have theorems, you have definitions, you have postulates. You're using those things you have already established to get to the next step. So here, it says a proof is a convincing argument that uses deductive reasoning. Shouldn't just be subjectively convincing. It should be objective if you're doing it right. And the style we're going to use, there's many different styles of proof. We're going to use a two-column proof here where you have the statements you make on the left and then the reasons for those statements on the right. So let's look at this example. So they want us to prove the vertical angle theorem. The vertical angle theorem, again, says if you have vertical angles here, they're going to be congruent. So angle 1 and angle 2 are vertical angles. So that's what we're given, and we want to prove that angle 1 and angle 2 are congruent. Okay, so the first thing you want to do in every proof is state what is given to you. So if we look at what they put for the first one, they wrote what was right here, word for word, letter for letter, number for number, symbol for symbol, exactly as it was put here. So angle 1 and angle 2 are vertical angles. Why do we know that's true? We know that's true because that was given to us. That is given to us. They tell us that's true, so we can use that as our first step. So no matter what, you should always get the first step right because it's literally every single time in a two-column proof, it's just simply rewriting the given. All right. So now what I do here is I look at what we're trying to prove. We're trying to prove that angle 1 is congruent to angle 2. So usually, in order to prove that they're congruent, you need to show that their measures are equal. So in my head on the side, I'm going to be going, okay, we got to somehow show that the measure of angle 1 equals the measure of angle 2. So I somehow here, using the diagram and the theorems and postulates and definitions that we know, need to get to this step here to show that the measure of angle 1 equals the measure of angle 2. And from there, I'll be able to say angle 1 is congruent to angle 2. So I know this is probably how it's going to end. Okay, and if I were to look ahead, right, and I could show you, yeah, this is exactly how it's going to end here. Okay, we got to do this other stuff to get there, but this right here is how it's going to end. So let's see how we can do that. And if we want to take a peek at what they did, right, they use supplementary angles. Okay, so there's many different ways to do this. Sometimes you can do it very extensively where you say every step fully, and other times where you don't use every step fully. And this is where it frustrates me that there's no consistency, and it frustrates me that that everyone's not doing it the same way every time. Okay. Normally, what I would say here is that you should have to say, okay, angle 1 and angle 3 are a linear pair, right? And that would be the definition of a linear pair. Okay, then you would have to use the linear pair theorem to say that they are supplementary. And then you would have to use the definition of supplementary to say that they measures add up to 180. They're skipping those 3 steps and just going straight to say, okay, the measure of angle 1 plus the measure of angle 3 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. Okay, so that's fine. All right. Okay, and since they both equal 180, right, since the measure of angle 1 plus the measure of angle 3 equals 180, and the measure of angle 2 plus the measure of angle 3 equals 180, that's called the transitive property, right? If 2 things equal the same thing, then they equal each other. So if A plus B, if A equals B and B equals C, then we know that A equals C, right? So if A and C both equal B, we know that A and C are equal. So here we have the measure of angle 1 plus the measure of angle 3 equals 180, but also the measure of angle 2 plus the measure of angle 3 equals 180. So we can set those equal to each other. Okay. And then what they're going to do is they're going to subtract the measure of angle 3 from both sides. Right? So if you subtract the measure of angle 3 on this side, right, we subtract it on that side and we subtract it on this side. Right? Those are going to cancel and you're going to be left with the measure of angle 1 equals the measure of angle 2. And that's the subtraction property of equality. That's just subtraction. Right? You subtract them from both sides. And then, as we said, once we know they're equal, we know by the definition of congruent, right? The definition of congruent angles, we know congruent angles have the same measure. We can then therefore conclude that our angles are congruent.